Hi friends, Don Wilson here with a very different episode of As the Record Turns. This one's going to be quite academic in nature, and it's also going to be quite long. This video will be approximately 30 minutes, the first 5 of which is going to be an explanation of what it is and some brief credits. So, what this video is about is how were diamond discs made? Specifically, how was that giant plate of wax taken and cut into what could then be plated and a master matrix and then a mother and then stampers made. So specifically we're focusing on the very first part, the cutting of the master of the diamond disc. This is something that's not very well known. There's a tremendous amount of information out there about cylinders, and a lot of assumptions are made that the technology is similar, but I don't believe that anybody has done any in-depth research on diamond discs. At this point, it's pretty well known that I have a fairly comprehensive catalog of some of the more desirable diamond discs, which I've reproduced using silicone molds and polyurethane, as you all well know from my other YouTube videos. But it would be nice to be able to create new diamond discs, and to do that we really have to go back in time, and we really have to examine the artifacts to find out exactly how it was done. So you've seen a lot of these videos, but not many of you know that research is part of what I do for my day job. I am a visiting researcher at a large university here in Philadelphia in the Department of Chemical Engineering, where I examine various waste, fats, oils, greases, and waxes, and the soap content they have, and breaking down lipids and glycerides and converting them into beneficial use, as opposed to landfilling or incinerating them and turning them into diesel fuel. So with a pretty well established knowledge of research and some academic abilities, I decided that this is a venture that I was going to jump into. After having produced my first diamond disc lathe, the results were quite poor. However, this is a rather small community, and as fate would have it, at the ARS conference last month, that's the Association for Recorded Sound Collections, I had run into one Mr. Jerry Fabris, and when I contacted him more recently about trying to find out how a diamond disc lathe works, he had recalled that encounter, and we set up a meeting so that I was able to go to the Thomas Edison Museum and examine the remaining artifacts. So, to that end, before I continue, a tremendous thank you has to be given to those so far involved, and that is the Thomas Edison National Historical Park, which is part of the National Park Service, the United States Department of the Interior, and Jerry Fabris, F-A-B-R-I-S, is the museum curator of the Thomas Edison National Historical Park. It takes an institution such as the United States National Park Service to be able to fund something like the Thomas Edison National Historical Park. It's an enormous undertaking. They have mountains of documents and buildings full of artifacts that only a large institution could afford to maintain. So we all of us collectors owe a debt of gratitude for them for taking such good care of these things that we hold so dearly, and also to making them available to people such as myself I took many pictures while I was there. Jerry was kind enough to dig out all of the what they believe to be all of the diamond disc cutting heads, both acoustic and electric, and I've photographed all of them, and I have them all in this presentation that I'm about to show you. So with that, let us begin. And one other, I guess two other quick things, is that I present this to you not as an expert. I present this to you as somebody who knows very, very little about this process. I've not cut cylinders. I've very poorly cut diamond discs. This is the beginning of an exploration, and for those of you that already have knowledge, such as those of you who are experts at cutting cylinders, one or two of you might see this video. I hope that you'll contact me for guidance where I'm wrong. And for those of you that see something that you suspect is incorrect, or if you have a difference of opinion, I really hope that you'll contact me. And with that said, what I present here, for the sake of brevity, I'm not going to give the disclaimer for every fact saying, this is my opinion, or, this is what I think might be the case. This is all my opinion. A lot of it is formed on cutting 78s with a vintage 1940 lathe, and speculation as to how machineries and industrial processes work. But none of this should be taken as fact. So with that, let's get going. Okay, so this part here you know quite well. We have a 2-minute cutter. This is one that's for home use. Many of you have seen these. They're fairly common, where we simply have a diaphragm of approximately 1 inch. We have the horn connector of approximately 1/2 inch, and then we have this stylus rod and a stylus of approximately 1 millimeter. This is a slightly different design. I believe this is an older design. I believe that because it has the adjustment rod on the end, or the adjustment lever on the end, similar to the automatic reproducer. And they probably stopped making this one because look at that. That's a lot of parts. It looks really expensive to make. And it has this nice little arm, which is really similar to the diamond disc reproducer. If we take a close look at the stylus for it, we'll see that it is concave and that it is round with a relatively sharp perimeter. It was pointed out by one of the cylinder experts on Facebook recently, who I'm not naming simply because I haven't asked him for permission to quote him yet, that this is the ideal configuration because it produces the cleanest cut and also pushes the swarf out of the way. The swarf is the fine thread of wax which is continually being removed from the cylinder. Swarf Control is a real problem with cutting. It builds up like a ball, and it can really clog up the works and generate a lot of interference. So here's the first cutting head that's photographed. I'm not going to talk too much about this one because it is too incomplete. But this one is much more complete. And it's worth noting that none of the ones that were available had the stylus connected. There's one that we'll see at the very end that has the stylus bar. No, actually I believe we'll see that soon. But regardless, there's one that has the stylus bar connected, but unfortunately finding one with a stylus was not possible. So if we look at this, we can notice that there's two things worth pointing out. That it's very similar to a commercial cylinder recorder. The Now the difference between the home cylinder recorders and the commercial cylinder recorders are the features that we see here. Because the diamond disc recorders and the cylinder recorders that I was able to see, they work quite similar. But in regards to home cylinder recorders and the commercial ones, the big difference is this lead ball. This lead ball would sit on the wax in advance of the cutting stylus, and I think that this was a sort of pressure control, that it would ride on the wax, and if there was a high spot or a low spot on the wax, as minute as it might be, that it would prevent the cutting stylus from either digging in or floating up above. We also have this tensioning wire, and this tensioning wire is a suspension system for this advanced ball. I believe that the cutting stylus would mount along here on some variations, and on this side of this cut, there's another cut here which causes this to act as a sort of a spring. Now, in regards to the differences between the cylinder cutting heads and the diamond disc cutting heads, there are two main differences. Now, I didn't take accurate measurements, but just simply by looking at them, it was pretty clear to see that the diameter of the diaphragm is considerably larger on the diamond disc cutting heads. These diaphragms are approximately 1.5 inches, whereas the cylinder diaphragms were approximately 1 inch. Also, the horn connector was, the one on the commercial cylinder cutting heads looked slightly smaller than that of what you would find on a home unit. So maybe 3/8 or a little smaller than 1/2 inch. Whereas on this guy it looked more like 3/4 of an inch. It was quite a significant difference. On this one you can see that split here, which causes the portion of this crossbar with the advanced ball here being broken off, but just the same, where you can see this being able to act as that spring. And of course, with this being a commercial product, there are adjustments all over the place. You can see these screws for tensioning this cable, and also adjustments on this crossbar. One feature that we weren't real clear on what it was is this little triangle here, which I'm going to speculate is for Swarf Control to push it out of the way, but I have no idea whether or not that's the case. That's at this point, that's simply my only guess. Here's a slightly different design. As we can see by the blue, I believe that this piece is spring steel, and that spring was somehow a cutting stylus adjustment. On this one here, we can see on the diaphragm that there's the addition of this piece of cork. And this cork, it really looks quite similar to a diamond disc diaphragm, having that bit of cork there. Also notice that there's more adjustments and more adjustments, just as we would expect to see on such a product. I'm assuming that these were also built in-house, and notice the exceptional craftsmanship of these. With all of these components that we're going to examine, the level of craftsmanship is absolutely spectacular. However, the roughness with that many of these fasteners were treated with after the fact, I think suggests that they were later cannibalized for parts. Once one spends so many dozens of hours building such a beautiful piece of brass and spring steel, they're not going to run in the flathead screws like an idiot with the wrong size screwdriver. They're going to take great care, as would the person that's using this for their job every day. Now this one does have the stylus bar attached. The stylus is missing, but we can show there it sits just behind the advance ball. And here's this adjustment mechanism, which I don't know what it does. Also, we can see that here's a diaphragm that has something added to it, like that piece of cork. We can see that it's glued on. It looks like rubber, but I don't know what it is. Now we're moving right along to the electric cutting heads. You can't tell by the picture, but these are absolutely massive. The acoustic ones were slightly larger than the cylinder cutting heads, maybe quite a bit larger. But there's no comparison between them and the electric ones. These electric ones are massive. And you'll see in a few photographs later where I'm holding one in my hand, and it's just gigantic. Many of the components that are up against the disc are similar. You can see here a tensioning wire, but I believe that all of the other peripheral components are missing from this one. It is fun to see that here it is, a great big horseshoe magnet, just like we probably played with in middle school, though. This one here looks quite a bit later. You'll notice a much more refined, streamlined design. I take that as a hint, a visual cue that it's moved along several generations. There's another reason that I believe that. I believe that as well because if we zoom in on this one, we'll see that the cutting stylus of this one is mounted vertically inside the cutting head, and that the chiseled profile of it is that of a laterally cut disc. So this was for cutting 78s. When it's from or who made it is anybody's guess. If we look, we can see machinist's marks, or tool and die maker's marks more likely. The little crosses that center the holes that would have been punched and then drilled. I believe that this was probably made in-house. Edison did later use Western Electric for their technology, but who knows where this one came from. You'll notice here more of those tool and die maker's marks, marking exactly where to cut everything. And the precision, the fit and finish of this is just beautiful. This here, quite an early looking one. It almost looks like it's for Morse code more than for a cutting head. Really hard to believe that that could possibly make better fidelity than an acoustic recording, and God only knows if it did. The R&D labs, their inventory was joined with that of the factories, and the documentation has not been thoroughly gone through yet. So these items are all cataloged, but it's not thoroughly understood exactly by looking at them at a moment's notice, one can't tell where they came from or what they were used for. And then, of course, there's also the possibility of later modification for other uses. Here's another one with a lateral cutting stylus. Here we can see those pieces of peripheral equipment, which are just like those on the acoustic cutting heads. The adjuster and this tensioned wire, this crossbar with the spring finger and the lead ball. And there's that triangle again. Now you'll notice this in my hand, that it is larger than my hand and quite heavy. You can just see the massive amounts of metal that go into these. Okay, so now this starts to bring us to equipment, and this was an interesting guy. Now it's generally believed that the recording engineer cuts a disc to wax, and then that's it. Everybody just hopes that the engineer had all the equipment set up correctly and that the equipment performed properly, and that after that it's electroplated and then electrotyped and electrotyped again, and finally we have a stamper, and then we can make a first copy and see. But that's a very laborious process, and when one is paying a day's wage to Vaughn de Leith or the California Ramblers, I think somebody would probably get fired if they found out at the end of that all of the recordings were heavily distorted. So what this device is believed to be is to be a playback device for playing wax masters. It is believed to be a destructive process, but this would give the recording engineer the ability to do a test cut on one of the recording blanks, take it over to this machine, and then play it and see if it sounded okay. If everything was well, then that one would be sent back for being shaved, and a fresh blank would then be used with the same machine dialed in with its current settings. What's not known is that, so we clearly have a diamond disc reproducer chuck. I don't think anybody would dispute that. But what's really unusual are these series of holes with screens. They're quite a mystery, and no one has any guess as to what they might be. You'll notice there's also no horn on this machine, so I don't know. Maybe they just used that little bit of sound, and that was that. Here's the first lathe. I believe that we're going to see two. Many of them were incomplete. This one's also incomplete. It's missing the cutting head, but it was easy to photograph and well lit, so it was a good one to take a picture to give you the quick walkthrough. You'll notice there's an electrical hookup, and ironically that electrical hookup is only for a light bulb. Otherwise there are no electrical hookups on this. This is a spring-driven, hand-wound machine. Underneath here there are 4 gigantic spring barrels, much larger than anything that would be used for home use. And then all of this is probably 200 or 300 pounds of cast iron, except for the aluminum turntable. Why an aluminum turntable was needed, I have no idea, but there it is. This overhead crane is just incredibly robust. We have the mounting for the cutting head and the lever to raise and lower it, but again, no cutting head. And you'll also notice that nothing in this assembly is driven. It's just simply raised and lowered. It's this screw back here. It's a very coarse screw. It only has 2 or 3 turns. And that's what drives this entire turntable assembly below the cutting head. And everybody else would do it the other way around. The cutting head would move in the same orientation that a needle and a reproducer and a tone arm would move across the disc, but not here. Here we see the disc being moved underneath the cutting head. It's also moving on the other side of the spindle hole. I guessed that by the light and the lever. It's possible that I'm mistaken, but so far that's my theory. And the other thing that you can't see here is we have a belt that drives the turntable mechanism, but on the other side here there's another pulley that would a rope would be tied to this the knuckle, we'll call it, or the main casting for the turntable carriage. A rope is tied to here and then goes over a pulley on the other side with a weight attached to it to help drive it. So that also leads me to believe that we're moving in that direction. That would just counter what I said, but I'll figure it out later. Here we see the some Swarf Control. This is the last lathe we're going to look at. This was the most complete one that was available. This one has the cutting head. It does not have the stylus bar or the cutting stylus. We can, however, see the Swarf Control. It has a nozzle for compressed air to blow in, and then this larger one for vacuum to suck it all up. So most newer lathes simply have one nozzle to vacuum it up, but this has both. And here we can see the cutting head. We can see the electric light that's on this lathe. There's the vacuum and the compressed air line, and here's a microscope. Microscope has been a common fixture on lathes for a very long time. The lever to raise and lower the cutting head assembly. And you'll notice here that there is no spindle nut, which most lathes don't have, but there's also not a secondary post. Instead, there's these voids where, as we saw on the machine for playback, that there must have been some sort of a clamping system to hold that wax master. Now this is down below what its intended height would be. The wax master would have this up a little bit, but this is lowered to get an idea as to what the angle could be. I think that it would be fairly flat, or maybe down a little. We see this angle here and then leveled out. So this is the last one that I have for you. This is not a picture, but it is a 1 minute and 18-second long video, and this is that lathe that is the most complete one. And the purpose of this video, there's no audio to it except for some background chit-chat. The purpose of this was to show the entire machine, so that any all the components that were missed while trying to photograph them hopefully will be captured in this video, so it will give a full view of this machine. Right there is the rope and the pulley that would have the weight attached to it that I mentioned earlier. And there are those giant spring barrels. There would also be a chain drive that would go up. So this has been the first round of preliminary research that I'm doing. Again, I hope that those of you who have more experience or have had different results or come across interesting information will share that with me. This is going to be an ongoing research project, and I hope to have something more thorough for you in the next edition. Meanwhile, I hope that if you found this video enlightening, that you'll share it, and hopefully amongst the community we can piece together the details of how these wonderful recordings were made so long ago. Thanks so much for watching.